So we'll be continuing our talk now on properties of curves and the use of derivatives and their applications. And we'll extend this to inflections and shape, okay? Specifically curve sketching and how to use derivatives, first derivatives, second derivatives to sketch curves. And there's a couple words that you're going to need to know in order to do curve sketching with derivatives. The first one is concave down. Okay, if a curve is concave down, that means it's going to have this kind of shape for a certain interval. Okay, concave up means that it's going to have a curved shape where you kind of have a bowl. Okay, a concave down, I guess you kind of have a hill. Okay. And the way we test for this, we can find the concavity or the shape of the curve for a certain interval by looking at the second derivative. Okay, let's take a look at how the second derivative tells us what's happening. Okay, so if this is f of x, all right, let's start with concave down. If this is f of x, let's investigate what's happening with f prime of x. Okay. So if I have f prime of x here, and let's start over here. What's my tangent line going to be right there? Okay. Well, I'm going to have what's the slope of this line is going to be pretty big, right? As I move from left to right, let's move to the point over here. Okay, and I have a tangent over here. The slope of this line is bigger than the slope of this line, right? So you can see the slope is getting smaller over here. As I move over here, it's getting closer to 0. My slope is getting close to 0. Right at this point, my slope is 0. As I move over to more to the right, you're going to see the slope decreasing. Now my slope is negative. Okay, negative slope, positive slope, 0 slope, right? And I'm talking about slopes here. Okay, so you can the f prime of x on a concave down curve is going to have a decreasing f prime of x. The slopes will be decreasing as I go from left to right. When I say decreasing, I'm assuming I'm going from left to right, right? So what can we say about f prime of x then? Or sorry, f double prime of x. If I were to take the derivative of this, how fast is this changing? Okay, well we know that it's decreasing, okay, as I go from left to right. So if f prime of x is decreasing, then f double prime of x must be negative. Okay, so this must be negative. All right, so that's a key point to remember. For a concave down curve, the second derivative will always be negative on that interval. Okay, on the part that's concave down. So likewise, when we look at a concave up curve, okay, let's take a look at the graph. Let's investigate what's happening to the slopes here. What's the pattern of f prime of x? Here it's a very steep negative, so it's very negative. Here the slope is less negative. Here the slope is 0. Here the slope is positive, and here it's very positive. So you can see that I'm going from very negative, going up to 0, going up to very positive. Okay, so the pattern of f prime of x for a concave up curve is that it's increasing. And therefore, the second derivative of x must be positive. Okay, so this is very important to remember. A concave down curve has a second derivative that is negative on that interval, and a concave up curve has a second derivative that is positive on that curve. Okay, so that's positive on that curve. Okay, here are some examples. Let's take a look. Let's try to identify the intervals where the curve is concave up and where it's concave down. Obviously, this part, okay, we said this is concave up and this is concave down, right? So it's very easy. From here to here, okay, this would be concave down. Okay, from here to here it would be concave up. On this curve, from this side of the dashed line, we would expect it to be concave up, and so this side would be concave down. Okay, so I'm just giving you this to help you see and be able to identify where the graph is, or where the graph is concave down, where the graph is concave up. Okay, what about this one right here? This one's a little bit harder. Okay, so it looks like from here it's concave up, but right around here it switches and it goes down to concave. It goes to concave down. Okay, so somewhere in between here we're going to have a point where it switches suddenly from concave up to concave down. So over here you'd have f double prime of x, where it's positive, and down over here we would have f prime of x would be negative. Okay, so if I were to do the sign diagram for all of these, you could do this. Right here I'd have some point. Here the sign diagram of f double prime of x. This would be negative, this would be positive. This one would be positive, this one would be negative over here. Okay, and we're looking at just f double prime of x, the sign diagram of f double prime of x, right? And how do I know this? Because of this rule that we talked about up here. If it's concave down, f double prime is negative. If it's concave up, f double prime is positive. Okay? Let's try to identify what's happening here. Here we have concave down. Here we have concave up. Ooh, that looks kind of tricky. What's happening right here? Well, the curvature here is it's curving. It's kind of curving down this way, isn't it? So there's going to be a slight concave down, and then over here we're going to have a slight concave up. Okay, so you can see if I were to divide this up into intervals, you could probably see that somewhere between here and here we would have a change in curvature. Okay, somewhere between here and here we would have a change in curvature, and somewhere between here and here we would have a change in curvature. Okay, so the sign diagram for this ugly graph would be negative, right? Because it's concave down, negative, positive, negative, and positive. Okay, so we have 4 intervals here that are alternating for the f double prime of x. Okay, all right. Here's a nice way to remember these words. Concave up, if you're having trouble identifying the connecting the word with the shape. Okay, just think of it as this. The U is my concave up, and the N is my concave down. Okay, so if I see this kind of shape opening down, then it's going to be a concave down, and if I see it going up, then just think of the word U. Okay, U for up and N for down. All right. Let's move on to points of inflection. Okay, so if we come back to this, at each of these points over here, we had a change in curvature, okay? And that each of those points are called points of inflection, or inflection points. Okay, you might see this written as inflection with an X, but it's the same thing. All right? Points of inflection are points where a change in curvature occurs. That should be an S. Concave up to concave down as I move from left to right. Okay? Basically, as I read my sign diagram from left to right, am I experiencing a concave up switch to concave down? Okay? Or vice versa, concave down to concave up. So each of these points up here, in our examples, each of these points here, because you see a change in curvature, ooh, sorry, that should be a negative. My apologies there, that should be a negative. Okay? And this should be positive and negative there, like that, right? So each of these points here are points of inflection, and some of them are, and you can see that some of them look slightly different, and we'll talk about what those are. Okay. So there's two types of points of inflection. Oops, sorry. Two types of points of inflection points, and the first one is stationary, which we've already seen. Okay, stationary points have a shape that looks like this. Okay, but non-stationary points have a shape like this, where the tangent line is not horizontal, whereas in the stationary point of inflection, we have a tangent line that is horizontal. Okay, let's take a look at the sign diagrams of these two guys. For the stationary point of inflection, we have a sign diagram where of f prime of x, where on this side, okay, it's decreasing, right? The graph is decreasing, decreasing, decreasing. So that means that the derivatives on this side of the graph must be negative. Okay, the slopes are all negative on this side. On this side, they're still negative. Okay? And we talked about this. We saw this situation before when we said find the critical points or the stationary points of a function, and either they will be when this is 0, it will tell me that it's going to be a local max, local min, or a stationary point of inflection, and that's what this is, right? Okay, so in this case we have a stationary point of inflection. Let's look at what's happening over here. The derivative here is actually we're going to have to identify a couple more things to show what's happening on this curve. Right now, this is not the only critical point of this graph, is it? Okay, I have several points where the derivative is 0. Okay, I actually have a derivative here. Okay, and I have a critical point here, and I have a critical point here. Okay, I have two places where the derivative is 0. So on my sign diagram for the f prime of x, I should have, let's call that B, and let's call that C. Okay, so point B and point A, or sorry, point C should be on my f prime of x sign diagram, and in fact this should not even be here. Okay, that's not even a critical point. That's not even a point where f prime of x goes to 0, right? So let's delete that actually. Okay, I don't even need A to be present there. Okay, let's now create the sign diagram here. Here it's decreasing, so we would expect that to be negative. It's increasing on this interval, and on this interval it's decreasing again, right? Let's take a look at the double prime f double prime of x. What's happening? For the stationary point of inflection, on this interval we have concave up, and on this interval we have concave down. So we have going from, since it's concave up, this must be positive, and since it's concave down, this side must be negative. Okay, so we do have a change in curvature occurring right here. What about the non-stationary point? Okay, well, if I look at the non-stationary point, right now, point of inflection, I have a curvature of concave up. I have concave up on this side, and on this side I have concave down. Okay, so on this side of A, I'm going to have a positive second derivative, and on this side of A, I'm going to have a negative second derivative. Okay, so what do you notice about both of these two types of points of inflection? What's common about these two points of inflection? They both have a change in curvature. Okay, and what's different about these two situations? F prime of x on the stationary one has a f prime of x, f prime of a is 0. Here f prime of a is some number, so it's not 0. Alright, and it's not even on my sign diagram. okay, whereas on the stationary one it is on my sign diagram. Okay, so what can we conclude about this? Well, if I'm interested in looking at the characteristics of the point of inflection, okay, I can see that I need for a point of inflection to exist, right? I need to have a change in curvature. Okay, as I go from left to right, the concavity must change. I must go from concave up to concave down, or concave down to concave up. Okay, and both of these cases, you see that sign in that change in curvature. Okay, so that's the second condition. The first condition is for a point of inflection to exist, f double prime of a, okay, where a is the point that I'm interested in, must be equal to 0. All right, and that's what you see in both of these cases. We haven't really looked at that specifically, but you can trust me on that one. We'll do some examples where that's true. Okay, but the critical point, or the 0 on my sign diagram, indicates that that is a value of 0. Okay, if you go a little bit deeper into calculus, you will see that f double prime of a is either 0 or it's undefined. Okay, so either there's going to be a 0 or there's going to be a vertical asymptote, and those 2 points are the points that I need to consider when I'm drawing my sign diagram. But for the purposes of this course, you don't need to know this. Okay, for this HL or for this course, SL or HL course, we're only going to be looking at when you're never going to see a situation where the f double prime of a could be undefined. Okay, but just keep that in reference if you go to another course and you decide to study more. Okay, so these are the two conditions. F double prime of a must be 0, and f double prime of x must change signs as I go from left to right. Okay, and you can draw the sign diagram of f double prime of x to check that. Okay, here's a warning. Just because, and this is a common mistake that a lot of people make, just because the second derivative is 0, it does not mean that there's an inflection point at x equals a. Alright, because remember, for an inflection point to exist, I have to have two conditions where this must be true and there must be a change in concavity. So you need to check both situations, both conditions, before you conclude that there's a point of inflection there. Okay, let's take a look at an example where this to show what I mean by this. If I have f of x equals x to the 4th, I have a graph that looks like this, and you can check that on your calculator. F prime of x is 4x cubed. F double prime of x is 12x squared. Okay, at x equals 0, f double prime of 0 is 0. If I plug 0 into here, I would expect to see this side go to 0. So since my second derivative is 0, you would be tempted to say, oh, that must be a point of inflection. But it's not, because if you look at the graph, we have concave up and we have concave up. So my sign diagram for my f double prime of x is actually positive and positive at 0. So because there is no change in concavity, there is no inflection point. So don't assume that just because the second derivative goes to 0 at a point that there's an inflection point. That is a wrong conclusion there. Okay? Alright, we'll do some, and just to summarize what's happening, alright, if a curve is concave down, alright, then f double prime of x on that interval must be negative. If a curve is concave up, then f double prime of x on that interval must be positive. Okay, and if f double prime of x changes signs, okay, from positive to negative or from negative to positive at a particular point, and that point has a 0 there. Okay, sorry, that's not 0. Let me just erase that here. So that should be x. Okay. Okay. If a. Okay. If I have at a, if f double prime of x changes signs at x equals a. All right, and f double prime and f double prime of a is 0, then we have a point of inflection. Okay. How do I distinguish if it's stationary or non-stationary? Well, it's stationary if f prime of a is 0, right? If the derivative is 0, then it's stationary. If it's non-stationary if f prime of a, the first derivative, is not 0. Okay? And that's what we talked about earlier in this video. So that's just a quick summary of what this lesson is about. All right?